Okay, so 11.3, we're going to focus on just the determinants, okay? So evaluate 2 by 2 determinants. I'm going to give you a 2 by 2 matrix. It's going to be A, B, C, and D. Find the determinant. We are going to multiply diagonally. So we're going to take A times D, which is going to be AD in this case. And we will minus the other diagonals. We will minus B times C or C times B. Okay? So we can write BC or CB. That is not important. So a determinant can be found for any square matrix. A 2 by 2 is the easiest. Now what happens if it's not a 2 by 2 and we have a 3 by 3, like in this case? So if I give you a 3 by 3, the first entry will be A11, A12, A13. This one will be A21, A22, A23, A31, A32, and A33. Oops, A33. Okay, so that's the 3 by 3 matrix. To find the determinant of a 3 by 3, you would need to know how to find the determinant of a 2 by 2 because it starts out like this. You will take the first entry, which is A11. So you're going to take the first entry, which is A11. You will multiply the determinant over the remaining matrix, which is those guys over here. A22, A23, A32, and A33. Okay, that's step 1. Then you will subtract. You will now subtract this entry, which is A12. Yep, it's going to be confusing. Hold on tight. Then you're going to multiply the remaining, the 2 by 2, which is this guy. So it's going to be A21, A23, A31, and A33. So first entry multiplied by the determinant of a 2 by 2 minus second entry multiplied by the determinant of another 2 by 2. Then the third one will be addition. Add your third entry, which is, guess what? A13. And you're going to multiply the determinant of this guy over here. Can you guys see the pattern? And so that determinant is A21, A22, A31, and A32. We'll use those right there to define minors and cofactors on 3 and 4. Okay, so the minors are the 2 by 2 determinants from the 3 by 3 determinants denoted by Mij. So all that is this right here. This is the minor. This is another minor. And this is another minor. Those are minors because those are from the 3 by 3 determinant. Next is the cofactor. Okay. Cofactor for an n by n determinant A. A is a matrix. A is the name of the matrix. Okay. The cofactor of entry Aij in your book it uses, so denoted by Aij. So big capital A is the name of the matrix. Little a is an entry of that matrix. Is given by Aij equals -1 raised to the power of I plus j times the minor mij. Okay, so let's go ahead and copy that down and we'll look at it all together as one whole picture. So we know the minors are those 2 by 2s, okay? Now the cofactors are these. This is one cofactor. This is another one, and this is another one. So we have 3 cofactors here. And the reason, can you guys see how the signs switch? We started with a positive, and then we went to a negative cofactor, and then back to positive. And here's why the sign is switching. Can you see that there's a -1 in here, and it's being raised to an I and j, I plus j? This is a 1 and 1, so 1 I and 1 j. So 1 plus 1 will be a 2. So the negative number raised to a 2 would always be what? Positive. Okay. And then this one is 1 plus 2, that's 3. So negative number raised to a third power is obviously negative. And then m, this right here, is obviously representing what? A minus. Okay. So all of that right there. So that's one big old picture. So if you see, if we say cofactor or minor, that's what they're talking about. 5, expanding across a row or column is the process, or is a process to find the value of a determinant by multiplying each entry in any row or any column by its own cofactor and sum the results. Okay, so we're going to go through all the properties of the determinant. We have one example, and that's it. Property number 1, the value of a determinant changes sign if any 2 rows or any 2 columns are positive. You guys agree with that? Are switch or interchange. Okay, and we'll prove it. So the values of a determinant changes signs if we switch any 2 rows or any 2 columns. So the easiest and the quickest determinant will be a 2 by 2. So we'll do A, B, C, D. Okay. So how do we find the determinant of this? What's the formula? A times D minus C times B, or B times C. So that's the determinant of that. What if we switch 2 rows? So I'll do CD on the top and AB on the bottom. Let's see if the signs switch. This determinant is now C times B, or B times C. Is that the same? Yep. So we can write B times C minus what? AD. Look at the signs. This used to be a positive AD, is now a negative AD. This used to be a negative BC, it is now BC. So now the sign switched. If all the entries in one row or one column equal to 0, guess what the determinant of that is going to be? All the entries 0. When you multiply them, guess what happened? It's going to be 0, right? If 2 if any two rows or any two columns of a determinant have corresponding entries that are the same, the value of the determinant is, any wild guesses before we prove it? 1? Square? Okay, good guesses. Let's check it out to see what it equals to. So it's saying that if any two rows or any two columns are identical, so let's do 1, 2, 3, and 1, 2, 3. Those two rows are the same, right? And then this one, 4, 5, 6. This will help us find the determinant of a 3 by 3 as well. Let's see what the determinant is. So according to the determinant of a 3 by 3, we will take entry number 1. We will multiply it to the determinant of the 2 by 2 matrix, which is what? 2, 3, 5, and 6. Do we add next or do we subtract next? Subtract. Subtract what? 2. And we will multiply the determinant of the remaining 2 by 2, which are
1, 3, 4, 6.
1, 3, 4, 6. And then do we add next or subtract next? Add. And we will multiply by the remaining 2 by 2, which are 1, 2, 4, 5. All right, let's do the basic math. 1 times what? 2 times 6 is 12 minus 15, negative 3, minus 2 times the determinant of this green matrix is 1 times 6 is 6. Take away 4 times 3, that's 12. So 6 minus 12 is? Good. Plus 3 times the determinant of this purple matrix is? 1 times 5 is 5. 5 take away 4 times 2 is? Okay. Now let's work it out. What did you guys end up getting? What is it? 0? No? Max says no. Zen says 0. I don't know. You tell me. 0? 0. Okay. Yep. And that is true. Uh-huh.
So, the requirements to get 0 are
2 rows have to be identical. Or 2 columns. So if you see that in the future, should you even work it out? No. Saves you some time.
So, but the determinant changes. The determinant changes
If you switch any 2 rows or any 2 columns.
But that has no influence on like the solution to the equation.
Correct. The answer could be different numbers, but it's just the signs will switch. Okay, so if the determinant used to be negative 10, it's now positive 10. Okay. Next theorem. I think you need to flip over, I think. I'm on the next page. Is that on the next page as well? Yeah, okay. If any row or any column of a determinant is multiplied by a non-zero number, let's call it k, the value of the determinant is also changed by a factor of k. So it increases by that much more. So an example, a quick determinant will be 1, 2, 4, 6. Okay, give me that determinant really quickly. Negative 2 total, okay, 6 minus 8, which is negative 2. Perfect. So I'm going to go ahead and multiply one row by k, whatever k is. And it doesn't have to be an actual value. We'll prove it. So this is 1 times k and 2 times k. Right? I want to in and multiply the entire row 1 by k value. We're not changing row 2, so we'll keep it as that. Your final answer of the determinant should be how many k's? Negative 2k. Would you agree with the property? Let's see if the basic math holds. The determinant is going to say 1k times 6, which is 6k. Take away 2k times 4, which is 8k, which will give us how many k? Negative 2k. So if k is 10, it's now negative 20. If the entries of any row or any column of a determinant are multiplied by a non-zero number k again, and the result is added to the corresponding entries of another row or another column, the value of the determinant remains unchanged. Okay. Okay, so let's find the determinant of 3, 4, 5, and 2. What's that determinant? Negative? What is it? That's okay. 6 minus 20. Negative 14. Perfect. So it says, okay, well, I'm going to, if the entries of any row of a determinant are multiplied by a non-zero number, let's say I'm going to use negative 2. Okay? So I'm going to change row 1. I'm going to multiply by k value of negative 2. Okay. And I'm going, and that whole second language this is what it's saying. K is negative 2. So I'm highlighting this right here. So negative 2 times R2 plus R1. That whole language that's really pretty much the equation. K is any non-zero, so we have chosen to do negative 2. Okay. And it says added to the corresponding entries of another row. So let's see. Would you agree that I'm about to change row 1? Row 2 remains unchanged, so that's going to be rewritten as 2, 5, and 2. If we're changing row 1, what are the new 2 entries for row 1? Negative 7 and 0. I'm going to hold it tight so that way we can match up. I want you to try to do it to make sure you matches Joe's. Is it negative 7, comma, 0? If you don't, then I want you to speak up because we take negative 2, right, times row 2, which is 5. Would you guys agree? Negative 2 times 5 is negative 10. Add row 1, which is 3. So that's negative 7. Okay. Same thing with the second one. Negative 2 times 2 is negative 4. Negative 4 plus 4 is now 0. So now it said the result should be negative 14. Do you agree? Is the determinant still negative 14? It's negative 7 times 2 plus 2 times 5. That comes out to be?
0.
I'm sorry, 2 times 0. 5 times 0. And so that's going to be negative 14.
Oh, 14.
So all of those theorems are true. You have example 1. Find the determinant of each. I'm going to give you a few minutes to do those, both A and B. Once we're done on A and B and we check your answers, we are done. Once you're done with A, can you turn to a partner and make sure you guys have matching answers? What's the answer to 1A? Negative 2. Okay, sounds great. If you get stuck on B, let me know. Once I verify your answer to B, you can start home. so close, guys. So close. You're really, really close. No. No. No.
13.
Yes, you can turn your homework. Yes, you can turn your homework. No, not that one. Then you analyze it. Okay. 1 minus, yep. 6, 5, 8, yep. 1 times 3 is 3, right? 3 minus -10, but it's not -7, it's the same. Oh, you're so close. Not quite there. You got it? Okay, you can do your homework. Not quite.
She had her piece of chocolate 3 times.
18 plus 40. Fix it. This way. It's 18 plus 40. Oh,
I don't even know where
yeah, this is 68. Yeah. So now, oh my God. 12.
I also got negative
Okay, so now try it again. Yes.
Oh, yeah, I
Woo. It is.
I go after big number, I know it.
It's easy to do so, guys. It's easy to mess up. Yes, perfect. Yes. So close. It's your positive 50. I'm not a negative.
Like, no, it's just for that.
Yes, you got it. Sorry for homework, good night. So much better. Yes. Yeah, there you go.
Right there was
Yeah, good job. That's it.
Oh no, I hate those already.
Your matrix is 6, -5. You switch them, guess what happens? Signs are switched. Yes. Woo. It's easy to mix up a number. So, you got it? Yeah. Yeah. It's easy, but it's difficult. There you go. You mix up that sign. So the final answer should be a negative what?
169.
Yeah, 169. Oh, you're so close. What was the answer to A again?
-2.
-2, thank you.